general annuities, and it. So whenever you have got an annuity, make sure that when payments are quarterly, also interest is compounded quarterly. Obviously, you know that. When payments are monthly, interest must also be compounded monthly. So let's say you are given, okay, let's look at example 1.1 on page 1. In terms of an agreement with his creditors, Ivan makes payments of 1,200 into an account every 2 months. So obviously our payments are every 2 months, 2 months, 2 months, 2 months. Determine the accumulated value of these payments at the end of the term if interest is compounded quarterly. Now there's a problem now. So payments are 2 monthly, but interest is compounded quarterly. So we need to convert a monthly rate to a quarterly rate, and there are two ways. It's either you can use the formula or you can use the calculator. Right. So quickly, let's use the formula. So the formula will be 1 plus j over n to the power of n is equals to 1 plus j over m to the power of m. Right. So on the left side, you write what you are given, what you are looking for, and then on the right side, you write what you are given. So in our case, we are looking for a rate that is compounded 2 monthly. So you are now going to say 1 plus j over 6. Why 6?
Because it says it's 2 months.
So
2, 4,
6, 8, 10, 12. Good. So to the power of 6 again is equals to, then on the right side now you write what you are given, which is now 1 plus 0.135, right, divided by 4. Why 4?
Quarterly.
Because it's quarterly, yeah, and there are 4 quarters in a year, right, to the power of 4. So this is the formula way, but I will only explain this once, and then afterwards I'll explain the formula. I suggest you use the formula. Sorry, the calculator, because it's easy. Right. So now let's start. The first thing is to make the power to be 1. So this power, which is 6 here, it must be 1. Why? Because we want to get rid of this bracket. That's correct. So what do we do then? We divide both powers by 6. So if I divide this here by 6, and I also divide this here by 6, right? So my answer is going to be 1 plus j over 6, and the bracket now falls away, right? Which is equal to, open bracket, 1 plus 0.135 divided by 4 to the power of 4 over 6. So again, if you want, you can now start solving it here, or if you can use your brackets well, it's fine. Let's continue. Then you take this 1, it goes to that side. So it's now j over 6 is equals to, open bracket, 1 plus 0.135. It's now 13.425, let's say 52. Yeah, let's say 13.4252% per annum, but is compounded to monthly. It's compounded to monthly. So that is the first part, to get a rate that is compounded to monthly. So remember, whenever payments are made monthly, interest must also be compounded monthly, right? So this is using the using the formula. Now let's see how do we get the same answer using the calculator, right? So you can clear the screen. So let's go. We want to change, so quickly let's write what exactly do we want to change. So we are given 13 point, is it 5? Yes, 13.5%, and it's compounded quarterly. So it means there are 4 quarters in a year. Now we want to change this rate into a rate that is compounded 2 monthly, right? 2 monthly. So that is 6 compounds per year. So what do we do now using a calculator?
Can you come again?
We want to change 13.5% per annum with 4 quarters into a rate with 2 monthly periods. Yes. So how do we do? First of all, we must convert this one to an effective rate. So we say 4. So let's press 4 in our calculators. 4. Then you press the XY button. You press the XY button. It's next to enter. So it's 4. Then the XY button. So the 4 is for the 4 compounds or the 4 quarters. Yes. So now let us now put the rate now. That is 13.5. So 4 XY, then 13.5. Then you say second function, the PV button. So if you look closely there, the PV button in orange, that is written EFF. That EFF is for effective rate. What answer do you get?
14.198.
14.198. Now if you want, you can either copy down that answer or you can store it. So I'll go for the easy way. You press store, then you press amount. It simply means we have stored your answer in button number A. Okay, you can now press on to clear the screen. Now on. Yeah. Then we now want to find a rate now that is compounded 2 monthly. So you now say 6 on your calculator. 6. Again, the XY button. Then recall amount. So that answer now comes back. But if you did not store it, you must now put it manually. Right? So on your screen now, it must say 6, A. And then you now say second function, PMT. And then you get the same answer, which is
13.4.
yes, which is 13.4252. So that's how you find an equivalent rate if you are using a calculator, which I think is the easy way out. So always you must try to remember how to use the calculator. Now, so that's the first part which we had to do on example 1.1, whereby the payments are 2 monthly, but our interest is quarterly. So what we've done here now is to compute a rate that is compounded 2 monthly. Now let's go to the next part about annuities, which you also need to remember. The difference between an ordinary annuity and an annuity due. So you need to know what is the difference between these two. Now I will draw a timeline here and then I'll show you what is the difference. So that's 0, that's 1, that's 2, that's 3, and that's 4. So let's say our payment is there. That's your first payment, that's your second payment, that's your third payment, and that's your fourth payment. Now let's look at two things. If you have got your PV and this is an ordinary annuity, you are going to put your PV there at 0, so that your PV and your first payment are 1 period apart. So once you've got this scenario, it means you are dealing with an ordinary annuity. When your PV and your first payment are one, not 2 periods, but 1 period. And what do you mean by 1 period? If these are monthly, this must be a month. If these are yearly, this must all be a year. Now, let's look at the future value. So the future value will be there. Now, if you see that your future value and your last payment are on the same date, it means you are dealing again with an ordinary annuity. So once you have got one of these two features in your question, then you know that you are dealing with an ordinary annuity, and you don't do anything on your calculator. You just work with it in this mode. Now let's move on to an annuity due. Again, I'll draw another timeline here for an annuity due. 0, 1, 2, 3, and 4. Now I'll put a payment here, payment there, payment there, and payment there. Now I'll start again with my PV. If your present value and your first payment are on the same date, there you go. Present value, first payment, they are on the same date. It means you are dealing with an annuity due. Or if your future value and your last payment are 1 period apart, then again this one you are also dealing with an annuity due. So whenever you are given a question on annuities, first of all, draw your timeline, look at this and see if you are dealing with an annuity due or if you are dealing with an ordinary annuity. Now, quickly, if you are dealing with an annuity due, what exactly must you do on your calculator? So you are going to change the mode to BGN. So where is BGN? If you look closely on your FV button in orange, is written BGN/end. The FV button on top there written in orange, you will see there that it's BGN and /end. So if you want to put that BGN, you say second function, then you press the FV button. You will see there on your screen there will be now a BGN that shows there. That is if you are using Sharp. If you are using HP, please look for BEG. If I'm not mistaken, I think it's just below the FV button. That's where you find your BEG. So whenever you're dealing with an annuity due, change your machine first to BGN. And how do you remove BGN? The same way you put BGN, which is second function FV. It's now off. How do you put it? Second function FV. How do you remove it? Second function FV. So that's how you play around. So this is the difference between these two annuities, ordinary annuity and an annuity due. Now, let's not waste time on example 1.1 because it's already done for us. Let me just explain two things. On the first one here, they're saying at the end of the term. Now, as you can see that payments are being made at the beginning of each 2 months. It means your interest will be calculated when? At the end of month 62. So your FV will be at 62. But now your last payment is at
60.
So this means you are dealing with an with an annuity due. And what do? You put BGN. That's why you see there under the solution 1, there's BGN there. So the 1,200 is your PMT. Then the 5 times 6 plus 1. Why are we saying plus 1? Because of this extra 1 here, right? Or the other way that you can do it as well is you say 60 minus 2. So is another way. Since there are 2 monthly payments, you go 2 months back. Now if you go 2 months back, you get to minus 2. Remember, from 0 to to your left, you are now going to negative numbers. So if you go 1 month back, you go to -1. If you go 2 months back, you go to -2. Now you say 60, that's where the last payment is, minus -2. So 60 minus -2. The minus and the minus gives you a plus. So it will be 62 divided by 2. Why 2? Because there are 2 monthly payments. Now this gives you 31. The same answer as 5 times 6 plus 1. So you can decide. I'm not sure. Are there any questions?
So now, do you start counting from 0?
Yes. No. From where the first payment is. So
Okay.
in our case, the first payment is at 0. That's why I went 2 months back. Now let me give you another scenario. Let's say we are given a timeline, and then you are told here that there's 28, and here there's 100, and there's payment here, and there's payment here. So let's say you want to know how many payments are there between 28 and 100, and you are told that your payments are 2 monthly. So it means from 28, the next payment is at 30. The next one 30. But of course, you can't do this up to 100. So let's find a way that will make life easy. So what do? You go to the last payment, that is number 100. You now come to the first payment, that's number 28. So since there are 2 monthly, you go 2 months back. So that's 27, that's 26. So you say 100, which is 100, minus 26. Then the answer must be divided by 2. Why? Because there are 2 monthly payments. So what's 100 minus this? It gives you 74. 74 divided by 2 is 37. So it means there are 37 payments from from month 28 to month 100. Again, if it was 3 monthly, you go 3 months back. Back to 25. You say 100 minus 25 divided by 3. If again it's 4 months, you go 4 months back. So you can use this method to calculate your N. And remember, we say the N can be number of payments or number of compounds. Right, back to our example 1.1. 1.12 says, what is the FV at the end of year 5? Now, let's come here. Year 5 now is here. So if you put your FV there, you see now, your FV and your last payment are now on the same date. It means now this is an ordinary annuity. There you go. Your FV, last payment, same date. It means you are not dealing with an ordinary. So you must now remove the BGN. That's why you said on number 2, same numbers, but you must just remove the BGN. Why? Because you are not dealing with an ordinary annuity. So, yes.
So in this case, if we are talking about this one,
yes,
right, for the 5 years, so can we say 60 minus 2? We get
same answer.
58
No. 60 minus -2. Okay. Remember, this minus is part of the formula. So it's 60 minus -2.
Okay.
Yes.
Then we divide by 2.
That's correct. And you get 31. So it's the same here again. 5 times 6 plus 1 still gives you 31. But the only difference between the two is one has got BGN and one does not have BGN. Now let's move on to increasing annuities, which is now the tricky part. That is on at the bottom of page 1. Before we move on with this part, I want you to remember this: increasing annuities, right, or an increasing annuity, annuities, right? They share the same features, right, with same features with an ordinary annuity. So an increasing annuity shares the same features with an ordinary annuity. So which features are we talking about? Remember, if you still remember the timeline of an ordinary annuity, the one I just drew now. There you go. Now remember, we had PMT here, we had PMT there, we had PMT there, and we had PMT there. Now we agreed that the PV and the first payment are 1 period apart, and the FV and the last payment are on the
same date.
Now an increasing annuity shares the same features with an ordinary annuity. Which features now? This feature and this feature. So you know that if you are dealing with an increasing annuity, right, the first payment of an increasing annuity is always 1 period apart from the present value. So if you remember this, it will assist you. Now let's quickly move on to page 2 and see what does the formula say on page 2. So the formula for A, remember from your BC, we've got A, we've got S, and A is the present value and S is the future value. So remember this, A is the same as present value, S is the same as future value. Now let's look at the formula for A for an increasing annuity, which is equals to, then you open that bracket, 1 minus, you open another bracket again, 1 plus J divided by 1 plus I over M to the power of M times N, and then you close this bracket and then you divide everything by I over M minus J. Now if you want, you can put a bracket there, or no, it's still fine. Then you multiply everything by R. So the formula will always be given in the test, but still people fail. So why? It's because they don't understand the formula. So quickly, let's look at these variables. What is J? So this is the J there, the same as again this one. So J is your escalating rate, or the escalation rate. What is your I over M? This one we know it from general compound interest. So this is our interest rate. So if it is compounded monthly, you divide by, if your rate is compounded monthly, you
divide by 12.
That's correct. You divide by 12. If it's quarterly,
You divide by 4.
perfect. If it's 2 monthly,
By 6.
same thing applies again here. So remember, this and this is same thing, and then this J again and this J again, same thing. Now the M times, the small m times small n, remember this is the same as the big N, which is the number of payments. So whenever you are dealing with a question, ask yourself how many payments are there. That's your N. So don't worry to put it in this form. As long as you know that it's 20, you just put your 20 there. Then your R is your first payment. So this is your first payment. Okay. Now let's look at example 1.2. Let's look at example 1.2. A timeline is drawn for us there, but as I always advise, please learn how to draw your own timeline. Now, let's read the question. Mr. Brown signs a contract for the rental of a building for 20 years under the following terms. 2,400 for the first 5 years, escalating at so now let's draw that. Remember, a timeline starts with a straight line. So there we go at 0. So we are told that 2.4 per annum for the first 5 years. Okay, but remember your first 2.4 cannot come here. Why? Because remember, we have already said the PV and the first payment are 1 period apart. So even if they don't tell you that it's at the end of the year, you know that the first amount is at 1. Just like there on your timeline there. So the 2.4 is at 1, not at 0. Okay, so let's draw ours here. 2,400 up to year number 5. So you can, let's write here our 5 there. But now we don't know now how much is this. Why? Because it escalates every year. At what? Yes, it escalates at 4%. Remember, this is not the interest rate. This is now your J. If you still remember your formula. Remember, we said J is the escalating rate. Okay, let's go back to the question. It now says 3,000 per annum for the next 5 years. So it now starts with year number 6. So we are going to pay how much here? 3,000. But now in year number 7 now it won't be 3 anymore. It will have escalated by 5%. That's correct, by 5%. So that's for the next 5 years. So it's from 6 to 10. Remember, 5 plus 5 is 10. So that's the last one again. There you go. Another one there. Okay, and then let's go again. 3.8 for the next 10 years. So the next 10 years will start from number 11 to number 20. Remember, 5 plus 5, 10. Plus 10, 20. So there you go. The first one here is 3,800. But now the next one at 12 is not the same, but it will have increased by 6%. That's perfect, by 6%. So all these, they are not interest rate, but they are escalating rates or escalation rates. There you go. Okay. So the question now says, what is the present value of this contract if interest is calculated at 10% per annum? First thing, ask yourself, the frequency of my payments are yearly payments. My interest is also compounded annually because they are simply said per annum. So it means we're okay. There's no need to calculate an equivalent rate. Okay? So now, let's go. The question is asking for present value. Where? Here. At 0. But we have a problem now. We've got three different escalating annuities. So according to the notes, let's start with the furthest one, which is the 3.8. So let's go to 3.8. Let's go back to the theory that I gave you before. What did we say? An increasing annuity shares the same features with an ordinary annuity. One of those features is that the first payment is always 1 period apart with the present value. Now, if you keep this in your mind, you now come here. Okay, where's my first payment is at 11. So obviously my PV cannot be at 0, but it's only 1 period apart. So it means your PV of this annuity is at, remember, 1 period apart. If first payment is at 3.8, where is PV? Remember, PV can never be in front of payment. The first payment is, yes, the first payment is at 11. So 1 period is 10. Is at 10. So it means your PV of this annuity, this one, is here at 10. Right? So let's do that. So we know that we now say A10. Why A10? Because we want to know the PV at the end of year 10 is equals to, so 1 minus 1 plus j over 1 plus I over m to the power of m times n, then everything divided by I over m minus j, right? And then everything multiplied by r. So let's now put figures here. Okay, so we go 1 minus 1 plus, what is our j?
6%.
But you must now put it as a decimal, 0.06 divided by, what is our I?
6.
Our I is 10% per annum, right? So it's 1 plus 0.1. Now remember, if it was compounded quarterly, you would divide by 4. Yes, but for us it's compounded annually, so we just leave it as 1 plus 0.1. You close this. Then the power, remember I say the power is just the same as number of payments. Now how many payments are there between 11 and 20? Let's use our same method. 20 minus 10. Why 10? Remember our first payment is at 11. So since they are yearly, I go 1 year back. So 20 minus 10 is 10. So it means there are 10 payments. Or you can even count 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So the power is 10 for 10 payments. Divide by 0.1 minus 0.06. Right? Multiply by the first payment, which is 3,800. There you go. So now let's punch this in our calculators. Okay, sometimes, especially this part here, there's no need for you to punch 1 plus 0.06 because you can do this in your head. It's 1.06. But fine, I'll show you both ways. So let's open bracket. Let's punch this in our calculators. So let's, okay, I need to add another bracket there. Let me add this one, let me add that one. But this one, sometimes it's not necessary. So let's only use there. So let's open that bracket there, right? Then our 1 minus, then we'll open another bracket there. Now, inside here now, you must be careful. If you want to put it as it is, then you must open another bracket again for the top part. But if you can solve this in your head, there's no need to open a second bracket. You now say 1.06 divided by 1.1. So we've simply added this, right? And we got 1.06 divided by 1.1. Now let's close this bracket here. And remember, there's power of 10 as usual, second function, depreciation, and we put our power, which is 10. Then we now close this, the second.
Put brackets, then we simply write 10.
Yes, we simply put 10. There's no need to open brackets. Why? Because our power is only one number. If the power was a fraction, then yes, you must open a bracket. Okay, so now let's now so we've now done the top part from this bracket here. One, for now we simply ignored this one. It won't make your answer wrong. So we simply opened this one bracket, we put our 1, we minus, we open bracket, then we combine this to 1.06 divided by 1.1, close bracket, to the power of 10. Close again the second one. We now divide by. Now again here, you've got two options. You can punch it as it is, or you can solve it in your head. If you were to solve it in your head, it will be 0.04. Or let's say you want to punch it as it is. Now, since there are two numbers, you must now open another bracket there and say 0.1 minus 0.06. and you close the bracket. So it means you've done this bottom part here. Then, so let me add those brackets there. Right, for now you can ignore this one here. Ignore the big bracket, ignore the big bracket there. Okay, so let's continue. So we close that last bracket there at 0.06, right? Then we multiply by 3,800, right? And then what do we get?
I have a minus.
It must be wrong. So it means you did not punch something correctly. Start again.
Everything.
Yeah. Open bracket.
Open brackets.
1 minus.
1 minus.
Open bracket again. 1.06.
1.06.
Divided by 1.1.
Close bracket.
Close bracket, yes. To the power of 10. Close bracket. Divide by open bracket. 0.1 minus 0.06. Close bracket. Multiply by 3.8.
It's 29407.
With the same answer as in our notes, right? So it is 29,407.32, right? But now remember what we just agreed now, that the present value of that annuity is not at 11 but is at 10. So it means this answer here is our present value at year 10. Hence it's called A10. So if you come and put your answer there, it becomes 29,407.32. But remember, the question says find PV, and your PV is at 0. So what do we do now? If you check in your notes there, it goes to the second part where it takes the 29,407 as your future value, and then your I is your 10, and your N is 10 again. So what exactly are we doing here? So we are simply taking this answer from year 10, where to 0. Remember, we want to find the present value at 0. So we now take this answer from year 10 and to 0. So if I'm standing here, what do I call this figure here? Obviously, it's my future value because it's in the future. So it becomes 29,407.32 plus minus future value. Then your N, the number of compounds from 0 to 10, obviously is 10 because our interest is compounded annually. So compounded annually for 10 years, it means there are 10 compounds. Then your I is also 10, which is given in the question. And what are we looking for? We're looking for present value. So quickly, let's punch that one. 29,000.
Should we clear?
Yeah. 29,407.32 plus minus FV. Then your 10 is N, and 10 again is I. Then you compute PV. What do you get?
11,777.
Can you start calculating this? We said it was 29,000, which is our future value. Okay.
Which is our future value. Right? And then 10
is your N.
is our N. Then another 10 with our I. Then we compute
PV. What do you get?
29 minus 29.
11,000.
Clear your memory. Second function alpha 00. Second function alpha 00.
Okay. So we are saying.
What do you get, Namja?
I've got
11,333. Sorry.
7.
Yeah, that's correct.
So
Continue.
Future value. Then 10, which is my N. then 10 again, which is my I. Ne? Then I must compute future value again.
PV.
PV.
Yes.
Okay.
What do you get?
337.
11,337. So now it means now the present value of this annuity at 0 is 11,337. So I'm not going to do the second one, right? I've already shown you how to do this one. So again, for the second one, same procedure. You are going to first of all use this formula of A is equals to, get your answer, but remember that your answer is not at 0. Your answer is at 5. Because remember, we said the PV and your first payment must always be 1 period apart. So your answer for this annuity, for this one, is going to be at 5. Once you get this answer, you do the same thing again, you bring it back to 0. Right? And then again for this one is easy. Why? Because your first payment is already at 1. So the answer that you get here is automatically at 0. So you are now going to add all your 3 present values to give you one total PV at 0. So you are going to add this one brought back, and add this one, and you get your PV in total. But you can follow through the steps given into your notes, and please make sure that you get 28,851.53. So that is for the present value of an escalating annuity using the formula A is equals to 1 minus 1 plus J over 1 plus IM. Right, and let's now move on to page 3, which is the future value of an escalating annuity. Future value of an escalating annuity. So future value of an escalating annuity. Right, and the formula is given by S. Remember I said earlier on, S is equals to the future value, or S is the same as future value. So S is equals to then 1 plus I over M to the power of M times N minus 1 plus R to the power of M times N, everything divided by I over M minus R. Then you must multiply everything in this, multiply by R, the big R. And remember, I think by now you know that the big R means the first payment. Now this R again is the escalating rate. We could have used J again, it's just the same. It's the escalation rate, and is the same. So this R and also this R, they are both escalation rates. And remember, our I over M is our interest rate, as I've explained in the previous one. So that's interest rate there. Now, so this is, and remember, an escalating annuity shares the same features with an ordinary annuity. One of those features is the last payment and the future value are on the same date. So that's what you need to remember whenever you are talking about an escalating annuity. Now let's quickly look at example 1.3.
Can I ask something?
Yes.
How do you know if we are calculating this increasing annuity, and if we are...
The question will tell you, let's look at 1.3 and see. How do you know that you are dealing with an escalating annuity? You take out a policy that stipulates that the first payment of 1.2 is due at the end of the year, and thereafter annual payments increase by, there you see now, annual payments increase by. So automatically that means you are not paying the same amount, right? But your payments are going to increase annually. and they will increase by 5.
5%.
So that shows you that is an escalating annuity. I hope you answered there.
Yeah.
So the policy matures in 10 years time and the expected interest rate is 12% per annum. What amount can you expect to receive at the end of the time period, meaning our 10 years? So if you were to draw a timeline, which I always say, please know how to draw one. So that's 1 there, that's 2. I can skip all these numbers, go straight to 10. Now our first payment is 1,200. Our next payment is 1,260 as given in there. But if you do not know this, there's no need to put it. All you need is a first payment. You can put there, and you can put R there to show that that's your last payment. Now, the question is asking us for the future value. But we know that the future value and the last payment are on them same day. There we go. Now let's calculate our future value. S is equals to, okay, so let's go 1 plus, what is our interest rate? 0.12. So 0.12 close bracket to the power of, remember I said M times N is the same as the big N, and the big N is the same as the number of payments. Now how many payments are these? Yearly for 10 years. Obviously your power is 10. Then you minus open bracket 1 plus your escalating rate is 0.05. Please don't confuse escalating rate with interest rate. To the power of 10 again, right? Everything divided by 0.12 minus 0.05. Okay, now I'm out of space now, but remember that at the end here we would multiply by the big R, right? The big R there, hopefully you can see that. Okay, so let's punch it in our calculators. So I'm going to introduce another bracket there and a bracket there. There we go. For the two top numbers. So let's open a bracket. And then instead of saying 1 plus 0.12, we can just do it in our heads and say 1.12. But if you want to punch it as it is, then you must open again another bracket. Remember, the bracket that I've opened now is this one. So if you want to copy it as it is, it means you must open again another bracket there. 1 plus close to the power of 2. But I don't want to add unnecessary work. So let's go. Open bracket, which is the red one. Then we say 1.12. It means we've ignored these two brackets. I've done this in my head, right? So 1.12 to the power of, now how do we put power? Second function, depreciation, to the power of 10, and we minus 1.05 again to the power of 10. Then
we open a bracket for this one.
You don't open a bracket.
Oh, okay.
This one is what?
1.05. Yeah, this is 1. This is 1. This is a bracket, right? So 1.05 to the power of 10 again, and then you close. So the brackets that I've opened are only, I've opened only the red ones, which is this one and this one. But if you want to open these small ones, then copy it as it is. You open two brackets, that there. But yeah, you decide. So once we close the second top red bracket, we now divide by, right? So we open again another bracket. Why? Because I now want to put my denominator. So it's 0.12, which is there, minus 0.05. You close the bracket, which is there. Then we multiply by our first payment is 1,200. What do you get?
25,319.
That's correct.
I've got it.
25,319.20. 1.12 to the power of 10. Let's start. Open one bracket. 1.12 to the power of
Second function.
10 minus 1.05 to the power of 10, close bracket, divided by, open bracket, 0.12 minus 0.05, close bracket, times 1.2. Right, so your answer is 25,319.20 cents. So that's your future value there at the end of year 10, which is again the same answer as the one given to us in the notes using the long way or the manual way. So that concludes our chapter 1. Now I won't waste time to look at example 1.4 because it is just the same, but I'll just explain a few things there, then you can do that on your own. Now let's look at 1.4. We won't do the whole example. I'll just explain a few things and then you'll be able to continue. Example 1.4. So let's see. A parent wants to cover his daughter's university studies for 4 years, which will start in 6 years' time. Now, what this means now is this. If you have to draw your timeline, so 0, 1, you can skip all the way to 6. So what it means is, it is at this point that the daughter will now get into varsity. So this becomes the first year up to end of year 7. This becomes the second year up to end of year 8. Again, third year up to end of year 9. And fourth year up to end of year 10. So in 6 years' time means 6 years must first of all lapse before one can get into university. So it is at the end of year 6 or beginning of year 7. That's when the daughter will get into university. Now let's come back here. A parent wants to cover his daughter's university for 4 years, which will start in 6 years' time. How much should we invest now? So where is now here? Now is at 0. So how much should we invest now? Obviously, how much should we invest? We are looking for present value. There we go. So,
Okay, before you
yes.
continue, we're looking for present. Isn't it that 1,500? Our present value.
No. I haven't read that part.
Oh.
I've only read the first 2 lines, which is a parent wants to cover his daughter's university studies for 4 years, which will start in 6 years' time, which is this part here. 6 years' time, the child gets into university and it's a 4-year degree. That's the first line. The second line says, how much should we invest now? So obviously we're looking for
Present value.
yeah, because there's no way you can look for something that you are given, right? So they can never ask you for something that you are given. So how much should you invest now? So it means it's a once-off deposit. If it was monthly, then it would be PMT. If it's yearly, again PMT. But ours is now. Now, there are 2 conditions. If the annual fees are 15,000 at present and escalate at 8%. So now we've got we've got something here again. We've got the fees, which is now. So the fees now is how much? 15,000. So this becomes the present value of the fees now. Right? So there we go, fees now. But we are told that it escalates at 8% per annum. It means if you are studying this year, you are going to pay 15,000. But if you are going to study next year, that is, okay, let me put 2 here, let me put 3, let me squeeze 4, and let me squeeze 5. So if you are going to study next year, your fees would have gone up with 1.2. With the 8%. Yes, that is the 1.2. It's fine. So again, if you are going to study in 2 years' time, your fees would have gone up twice, which is once here and twice there. If you are going to study in year 3, your fees would have gone up 3 times, right? Which is once, twice, and thrice. Again, it will increase there for year 4. Again, it will increase there for year 5. And finally, it will increase there for year 6. So it is at this point, after this increment, that the child will now get into university. So let's see, how many times did the fees increase? 1, 2, 3, 4, 5, and 6. So the fees have increased 6 times before the daughter gets into university. So for now, this you must understand it. Okay, let's continue with our question. He can earn 7% per annum compounded. Now there is a problem. There is a problem. Remember, in the very first thing I said about annuities is when interest is compounded monthly. When payments are monthly, interest must also be compounded monthly. Now in our scenario here, our fees is annual fees. It means it's paid once every year, right? It's annual, so it's once every year, once a year. But now the interest now is compounded monthly. So before you even see the answer space, you must know that there's a problem here. What's the problem? The payments are yearly, but interest is compounded monthly. So we need to convert the monthly rate to an annual rate. When you look at the answer space, there they ask you, calculate the equivalent rate compounded annually. But you don't need this to know that you must work it out. So the moment you read up to here, in your mind, immediately, you must know that, okay, I must compute an equivalent rate compounded annually. Now let's do that. But we are not going to use the formula. We are actually going to use the calculator, right? So we are given, what are we given? We are given 7% compounded monthly. Now we are looking for a rate that is compounded annually. But at the end of the day, these two rates must be equal, or they must be equivalent, meaning they must be the same, or they must give us the same answer. So quickly, let's punch in our calculators. First of all, you press 12. So you press 12. Why 12? Because the rate that we want to change is compounded monthly, and there are 12 compounds in a year. Now you press your XY button. You press your XY button, right? So 12 XY button. Your XY button is next to enter. Please know your buttons. Know your buttons. You need to know your calculator, right? So 12 XY, right? And then we now put the rate, which is 7, which is the rate that we want to change. It's 7. And then we are looking for a rate that is compounded once a year, which is the same as the effective rate. So you say second function PV, which is that EFF. So your answer is so it's 12.7 second function PV, and that gives you 7.229. There you go. So let's keep it up to 3 decimals. 7.229 compounded annually. So this is per annum, compounded annually. Compounded annually. There you go. So let me do the last part with you, then the rest you do it on your own. Now, the next thing now is, we know that for us to know what to invest, we must first of all know our target. Remember, you don't just wake up and start investing without a target. So what must we do here? We need to know the present value of the fees. Remember, the second payment for fees is here, the third payment for fees is here, and the last payment for fees is there. As you know, ideally fees is paid at the beginning of the year. When you come to school, you pay your fees. You come to school, you pay your fees. So these are the 4 payments for fees. So if we can get this one, then we can get the present value of fees, right? But how do we get this? We know that for now the fees is 15, more or less like PV, and the fees will increase 6 times by what? By 8%. Is the same as invest 15,000 for 6 years at 8%. It's just the same thing. So let's calculate fees at the end of year 6. At end of year 6, which is equal to your 15,000 into, remember I'm using the formula, S is equals to A into 1 plus I over M to the power of M times N, same as compound interest. So 15, 1 plus, what is our escalating rate? Is 8%. 0.08. How many times is the fees going to increase? 6 times. What do you get? What do you get? Quickly, let's punch this. 15,000, open bracket, 1 plus 0.08, close bracket, second function to the power of 6. And you get 803.11. Again, as per our notes, 803.11. So it means now that this is the amount that will be paid at the end of, or let's say at the beginning of year 7, for the first year.
7 or 6?
7. Remember, 6 means end of year 6.
Okay.
Beginning of year 7. So it will be 23,803.11. Remember, I said you don't start investing if you don't know your target. But your target is not this target. Why? Because this amount is only for 1 year. So we must now know the amount for 4 years. So how do we do that? We know that the next amount will also increase at 8%. So this is like an escalating annuity, increasing at 8%. So same thing as we did before with that other question. Remember, there was our payment, it was increasing at 5%, and we computed the PV. Or let me use this one. The 3.8 was our first payment. It was escalating at 6%, and we used the formula to get our PV of 29 at the end of year 10. So the same principle applies here. You now have your first payment, you now have your escalating rate, so you can now use that A formula to get your PV, but now it will be at the end of year
8.
At the end of year. If your first payment is here, where is your PV on this timeline?
Yes, sir.
Hmm?
With the PV.
If your first payment is at the end of year 6, where is your PV?
5.
At the end of year 5. Remember we said 1 period back. So 6, you go back to 5. So your PV is going to be here. So this is going to be A5. So you get your answer there. Whatever answer you get here, right, you bring it there at 5. So it means this parent needs so much amount at the end of year 5 in order to pay fees for the next 4 years. Now once you have this answer here, then you can now come back at 0 and say, okay, when I'm standing here, what do I call this?
It's not present value. Future.
Remember, I am not standing here. I'm standing there at 0. So, what do you call an amount that is at the end of year 5? Yes, because it's in front of you. So, it's your future value. So, this becomes your future value. And then your N is 5 if you want to use an annual rate. If you want to use a monthly rate, it will be 60. That's 12 times 5. So, you can choose. Then, you must just compute your PV. So you can follow the steps given to you there in your notes and see if you can get to the right answer of 63,314.21. 63,314.21. That's your final answer. That's how much the person must invest. 63,314.21. So that's how much the person must invest. So you do 1.4 on your own and see if you understand what we are talking about. Now that concludes chapter 1. So you do again example 1.5 on your own and see if you have understood what we are talking about. So that concludes chapter 1. Let's now move on to chapter 2, which is on page 10. Page 10. Chapter 2, page 10, capital budgeting. So this is where you have got one or more projects and you want to decide if it is acceptable, or let's say if there are 2 projects, are they acceptable? So quickly, let's look at the methods that we use. The first one is the payback method. The second one, average rate of return, internal rate of return, and net present value. So in this course, the other ones you will do them at BTech level, but for now we are going to focus on 2, which is the internal rate of return and the net present value. Now,
so we are not going to look at the payback and the average.
That's exactly what I've just said.
Thank you.
So that's for the BTech. Or if you are doing management accounting 3, you also be are doing that. So let's not waste time on things that we don't do. Let's go to internal rate of return. So let's look at the definition given there. So the internal rate of return is the interest rate that will make the present value of cash inflows to be equal to the present value of cash outflows, right? Or it is the discount rate that equates the present value of cash inflows with the initial investment. Let's put this in a timeline and see what, or let's use the example in our books. Example 2.1. An investment of 5,100 promises to give an annual return of 2,180 for the next 3 years. So let's draw this here. So that's 0, that's 1, that's 2, and that's 3. Okay, so no need for that. Right, so an investment of 5.1. So I'm going to put my investment 5.1. Remember, when you are investing, money is going out. So you can show it with a negative sign. Okay, then it is going to promise a return of 2,180 for the next 3 years. So it means at the end of year 1, I'm going to receive 2,180. Year 2, 2,180. And year 3, 2,180. There you go. Now, what annual rate of interest is earned? Now remember, when they say what rate of interest is earned, is the same as calculate IRR. Is the same thing. So, what is this now? This is a rate that causes the present value of these payments, these 3 payments. We are going to find their PV. We bring back, we bring back, we bring back. So, it is a rate that causes this present value to be equal to 5.1, which is there. So it is a rate that causes this, the present value of the future cash flows, to be equal to the investment. So if I use that rate to bring back this back, I must get 5.1. So I'm going to teach you 2 methods. The other one, anyway, it's not like teaching you, it's like reminding you. Now, what do we call this 5.1? Let's say I'm standing at 0. What do we call this 5.1 here? If I'm standing here.
Is it not our present?
Yes, well, that's where we are, right? So, you now say 5,100. That's your present value. Then, what do we call this 3?
It's our future value.
What do we call?
Our payments.
So that's payments, 2,180 PMT. Now your N, remember I always say N is the same as number of payments. How many payments are there?
3.
So what are we looking for? We're looking for I. So let's do this. So 5,100 plus minus PV 2180 is your PMT, and 3 is your N, and compute I. What do you get?
Why is this one, 1/1?
That you need to know. That you need to know. Huh? Where's your I?
This one?
Yep. Please know your calculator before the June exams.
And computer, right? It's saying calculating.
Huh? Clear memory?
Okay, 510 plus minus PV 2180, which is our payments, 3, which is the number, then on computer, right?
What do you get?
It's 31.45.
Clear memory? Alright, can I see your machine if it's set on the correct mode? But I think it should be. Second function per year. It says 1. It's correct. Now redo that. What's wrong?
Okay, because when I put the PA, like the plus minus 1, I come with the wrong answer.
5.1 plus minus PV. Right? Then 2180 PMT. Then 3 is N. And compute I. What do you get? I see now. It's because your machine there's BGN.
Oh,
We are not dealing with an annuity Jew. Now compute I. What do you get?
13.5.
Yeah?
Because I didn't get that one.
Plus minus. Compute.
Is the machine set at BGN?
It's right. It's right.
Okay, let's go. 5.1 plus minus PV 2180 PMT 3 N compute I.
Okay, got it.
Okay, so the answer is 13.5456%. So that is the rate that causes the present value of these three amounts to be equal to 5.1, which is also called our internal rate of return. Okay, now let's use another way. What if the amounts were not the same? Then you have a problem. Or if one amount was at 1, the other one was at 4, the other one at 5. Remember, this method only works if the amounts are the same. And they are also at regular intervals, meaning they are all at the end of year 1, 2, 3, or 3, 4, 5, or 5, 6, 7. But if they are not the same, or one is at 1, one is at 5, and one is at 6, then is a problem, as you will see as you continue with your notes. Now let me show you another way which we are going to use for many of our questions here. So that method is 5,100, which is this one, which is the investment, plus minus enter. So 5,100 plus minus enter. So your machine must now say data CF 0. It means you have entered cash flow 0, right? So your machine must say data set CF 0. Now you go to the next one, 2,180. Then again enter. 2,180 enter. 2180 enter. Now it now says 1. Now since the amount is the same, just say enter up until you see 3, right? Once you see 3, it means you have entered all the figures. So but if the amounts were not the same, you must now enter one by one. You punch it, you say enter, you punch it, enter. But in our case, it's the same amount. So I simply say 2180, enter, up until I see 3 for year 3. Then you say second function, CFI. Second function, CFI. Right? What do you see there?
Which one is CFI?
CFI is above enter.
Okay.
Right. I want you to press second function mode.
Again after this.
Okay. Second function mode. It clears not the memory, but it clears that rate. Right. As you can see there, above mode is CA for clear all. We are not clearing the memory, but we are clearing the entry of rate there. So I wanted to press the down arrow for now. Press the down arrow. What do you see? Now net PV is 0, right? Good. Let's come back here to our question. Remember we said an internal rate of return is a rate that causes the present value to be equal to the investment. Now, if you say 5.1 minus 5.1, what do you get? 0. So it means our NPV is 0. But I want you to remember this. Now, let's come back to our machine. So you see the NPV is 0. So that's perfect. Let's press the up arrow. Now we want to calculate that rate there. So once you say a second function CFI, your screen will take you to that rate there. Now you simply press compute. What do you get?
13.5.
There you go. Same answer, 13.54559, which is your internal rate of return, or a rate that gives you, so enter times 3. Then you say second function, CFI. Then it will take you to a rate. Then you simply press compute. Then your answer is 13 point what. Okay, so that's using the calculator. Now let's look at example 2.2. Right, example 2.2. This was example 2.1. Let's look at example 2.2. Example 2.2. There we go. Right, let's see. The same problem as above, except that the first inflow is received at the end of year 3. So let's look at our timeline, or let me draw mine here. That is 0, 1, 2, 3, 4, and 5. Now in this one now, the first payment is at 3, which is 2,180. 2,180. 2,180. There you go. Again, the investment is still 5,100, and it's a negative, because remember, whenever you are investing, money is going out of your pocket. Okay. Now, let's look at this. Let's look at this scenario here. If you are using the PV stuff, the PV PMT, you would first of all get your PV here, but now you can't even do that because you don't have your rate. So the only way now that we must use here is the CFI function. But remember, your payments are annually. There, 3, 4, and 5. It means every year you must enter something. But at 1, you see there's nothing. So we are going to enter 0. At 2 also, there's nothing. So we are also going to enter 0. So let's do that. 5,100 plus minus, remember, clear the memory first of all. Second function, alpha 0, 0. So let's go. 5.1 plus minus, enter. Now with this one now, don't forget the plus minus for the investment, because money is going out. Now you say 0, and you say enter twice. So 0, enter twice. Why twice? Because there are 2 years with nothing. So 0, enter times 2. 0, enter, enter. Up until it takes you to 2. Then you now say 2180. You enter 3 times. 1, 2, and 3. Why 3 times? Because there are 3 annual payments.
Sorry, you said, just a little bit. You said it was to clear memory. We said second function.
Alpha 0, 0.
Okay.
Alpha 0, 0. Okay. So let's go now. 5.1, enter. Then 0, enter, enter for the 2 amounts. Then 2,180, enter times 3, because there are 3 amounts. So your machine must now say CF5, right? For the 5, yes, where you lost. Second function, alpha 0, 0. 5.1 plus minus, enter. 0, enter, enter. 2180, enter, enter, enter. What do you see now? 5. So second function, CFI. Again, we are looking for a rate that will give us an NPV of 0. So we simply say compute. What do you get?
6.4.
That's correct. 6.45. There you go. So here, don't forget, second function, CFI. Then you compute and you get this. 6.45, which is again the answer on page 11. Right. Now, quickly, in the last few minutes, let us look at the net present value, which is more or less the same steps. Let's look at page 11. There are about 3 things I need you to understand, or 2. We would what to call the cost of capital, which is, I will give you an example. So this is net present value. Let's say you want to invest in a shop. So let's say you want to buy a shop, right? But to buy this shop, you are going to get a loan from ABSA. And this loan costs you 10% per annum, right? So this is what you call the cost of capital. This one is called the cost of capital. Because remember, this is your capital, right? And this is how much it costs you to use that capital. So the 10% is a cost of capital. So in simple terms, the return of this shop must be big enough to allow you to recover your cost. So if your return is 9%, so definitely there's no need to waste time, because the cost is more than the return. So yeah, you don't invest, right? You don't invest. But if the return is, let's say, 10.5, and the cost of capital is 10%, so obviously you must invest, because the return is more than the cost. Now, sometimes they'll give you cost of capital, sometimes they'll give you a required rate of return. It's just the same thing. Okay, so let's look at example 2.3. Oh, but before we go there, let's look at that formula. NPV is equals to present value of cash inflows minus present value of cash outflows. So you must remember that. Okay, so let's look at the first one. If NPV is positive, you must invest. But if NPV is negative, don't invest. So we are saying if NPV is positive, then invest. But if NPV is negative, then don't invest. So how do we calculate NPV? Let's read example 2.3. Example 2.3. Okay. A shopping complex may be purchased for 1 million. So obviously 1 million is our investment. So 1 million, I write it in brackets. Why? Because I'm going to purchase, so money is going out. It is expected that it will retain a uniform cash flow of 180,000 per year for the next 10 years. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And per year, we're receiving how much? 180,000. 180,000. Same, and 180,000. Okay. Now, if the cost of capital is 11.5, should the investor buy the complex? So we are going to use a cost of capital of 11.5. Should we invest? What about if it's 12.5? So let's start with cost of capital. Cost of capital at what? At 11.5. Good. And then again, we'll do cost of capital.
12.5.
At what? 12.5. Okay. All right. So we want to calculate the net present value. Now let's take our calculators as usual. Second function alpha 0, 0. Second function alpha 0, 0. Okay, 1 million plus minus enter. Then 180,000 and you press enter 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You only do that if the amounts are the same. If they are different, you enter one by one. Now, second function, CFI. Now, unlike before, when we said compute, this time we are given the rate. It's 11.5. So you say 11.5, enter. So don't forget enter. If you don't enter, it means it's not in. So 11.5, enter. Then you press the down arrow. It now takes you to, then you press compute. What do you get? 38,198.73. What this means is your present value of cash flows is more than the present value of the investment by how much? By 38,000. So if you agree with me, it simply means our present value of cash flows is equals to 1 million. What do that million there? 1,038,198.73. So that is the present value of cash flows, and the present value of the investment, we know it is how much? It's 1 million. Right, there you go. So that if you say this minus this, it gives you
38.
There you go. Perfect. There. So let's come here. Now don't clear the memory, because it's the same information. Just go back, press the up arrow to go back to your rate. Then say 12.5. Enter. 12.5, enter. Press the down arrow again. Then compute. What do you get? Minus 3,442.45. This means the present value of cash flows is less than the 1 million. Right? Why? Because our NPV is negative. So it means this one is, okay, let's see. 1 million minus 3,442.45 is equals to 99. So it means the PV of cash inflows is equals to 996,557.55. And if you minus 1 million, there you go, you will see that you get a negative number. Now, there's one thing that we want to check here. So let's add an extra column and write here internal rate of return. Don't clear the memory. Let's go back again. Okay, sorry, I've cleared my stuff. Okay, there you go. So where are we now?
We are on the net present value.
Okay, we are at NPV. Press second function mode. So we have cleared that NPV, right? Second function CFI.
Second function, CFI. Okay.
Where are you now?
She's on the right.
Go down.
NPV.
Go up. I need to see if you enter something. Compute.
12.4.
Okay, good. So, Nampia, go back to your rate.
I am on your right.
Okay, press compute. What do you get?
12.41.
Yeah. So it means your internal rate of return is 12.41. Now remember, we said at internal rate of return. Okay, so remember we said the NPV is 0 at IRR. Why? Because the present value of cash inflows is 1 million, and the PV again of the investment is also 1 million. So 1 million minus 1 million is
0.
Remember we said internal rate of return is a rate that causes the present value, right, of inflows to be equal to the present value of the investment. So at IRR, NPV is 0. So let's conclude something here. So our IRR is 12.41. So can you see that when cost of capital is more than the internal rate of return, like here, 12.51 is more than 12.4, it means NPV will be negative. There it is. Then if cost of capital is less than the internal rate of return, it means NPV will be positive. As you can see there, 11.5 NPV is why? Because 11.5 is less than our internal rate of return of 12.41. Right? So as far as NPV is concerned, this is all you need to know. And let's conclude our chapter 2 with page 12, which is profitability index. Profitability index. So let's go there. Profitability index. Oh, by the way, before I forget, when we are choosing projects, right? Okay, I think I have to write it somewhere. Okay, I will summarize that at the end. So let's move on to PI. So how do we calculate the PI? PI is equals to NPV plus initial investment divided by initial investment. So let's go. PI is equals to NPV plus initial investment, right, divided by initial investment. Initial investment. Okay, so without wasting time, I want us to use the ones that we've already done here. So let's calculate PI using 11.5. 11.5%. Let's calculate our PI. So remember, we said it is NPV, which is this one, plus the investment that gives you 1,038,000, right? So it's 1,038,000, 198.73 divided by your investment, and your investment is 1 million. There you go, 1 million. What do you get? 1,038,000 divided by 1 million. What do you get?
8198.
Yes. What do you get?
Is this 35?
73.
0.1.
It's 1,038,000, 198.73 divided by 1 million, right? That gives you 1.03, right? So 1.03